Welcome to this video. This is one of a series of videos that will talk about the key technical innovations of Thinkium blockchain. In particular, this video will mainly focus on the scalability. We know that scalability is one of the most important performance metrics for our blockchain systems. In particular, Thinkium blockchain achieves its high scalability through its unique design of a multi-layer, multi-chain structure. So today, we'll mainly talk about how this multi-layer, multi-chain structure is designed. And to better illustrate the process, we can show some diagrams. So in particular, there is a main chain, main blockchain, as shown here. We call it the main chain. And this main chain is working as a traffic hub that connecting all other chains later on. It is specifically responsible for recording, coordinating, and scheduling. Then for each specific business, for example, business one, it can create its own chains. Each specific chain can be considered as a subchain. We call it subchain. Then we can have different subchains for different transaction types. For example, this subchain can be used mainly for financial services. This same business can create another subchain. It's designed for example, some logistics. So then each of those subchains can work independently. And those subchains can all connect to the main chain. So in this way, we can also enable communications between different subchains. We call it cross-chain communication. Cross-chain. And those cross-chain communications can be enabled based on the evidence provided by the main chain. So that is how those chains can interact with each other. Furthermore, for those subchains, they can also form a parent and children relationship. Assume for this subchain 1 and this subchain 2, we can have subchain 1 as a parent of subchain 2. And this parent and children relationship can be recorded on the main chain. Then the benefit is that the children chains can inherit the properties from the parent chain directly. And in this way, we can easily extend the chains to with its own properties further down. So that's a relationship. Another key technique is the sharding. Given a specific chain, for example, like this one, typically we need to have the transactions validated before they can be posted on the block. Well, to validate a specific transaction, we usually have to have a group of nodes working as validators. Okay, so like this way. Those nodes are actually connected, or they can communicate with one another. Typically, all the validators needs to validate a specific transaction so that the transaction, after achieving the consensus, can be posted on the block. Well, with the sharding technique, we no longer have all the validators involved in every single transaction together. Rather, we actually separate those validators into different committees. For example, we can randomly assign those validators into different committees. For example, some of the validators could be assigned to committee 1, and the others can be committee 2 in this way. So with that being said, transactions can be generated from those committees. And we can have, say, other committees. Some other nodes, for example, can work for committee 3. So in this way, each committee can generate their own transactions, validate their own transactions. Then the different shards can be created. For example, the node marked in red can generate shard let's say 3. And then the nodes marked in green can generate the shards. We can say shard 1. And the node in black can generate another different shard. We say shard 2. So in this way, we can generate blocks much faster than having all the validators validating all the transactions. That is what we call the sharding techniques. When congestion occurs, the different business requests can be spread over different segments through the sharding techniques. In this way, the throughputs can be improved. Particularly when the number of shards increases, the throughput can increase linearly. A particular shard itself is also an independent chain, so they can work independently. Again, the cross-shard transactions can be enabled. With Thinkium, we provide optimization solutions to speed up the execution of those cross-shard transactions. In summary, this multi-layer, multi-chain structure of Thinkium can be dynamic and scalable. As a result, an individual chain will not become the bottleneck of the entire network. More importantly, with the increasing number of chains, the throughputs of the system can increase linearly, which is very important. And that's the key features of how Thinkium can achieve its high scalability.